Okay, so Cartesian products exercise 8, the last two questions, 3 and 4, use the same idea, and that's this. If we want to use this idea that the number of elements, that's n for number of elements, in the Cartesian product A cross B and the Cartesian product A cross C, notice this and, we can simplify this because A is in both. We can see here the set A, and if we're taking both of the elements that are going to be in the ones including B, when we take the cross product with B and the cross product with C, we can simplify this by saying it's going to be the number of elements in the set A with the cross product of just the ones that are in both, in B and C. So we can see we've made this expression a little bit simpler, and this idea is going to be really important to help us in these last two questions. So let's continue this. We're told that the number of elements in A cross B times and the intersection with A cross C is equal to 24. So what we can say is that the number of elements in A, where that intersects with B and C, because A is in both, remember, intersects with cross product with B and C, equal to 24 there. But now we also understand that the number of elements here in the cross product is going to be the same when we take the number. It's just the same as when we take the number of elements in either set. So it's the number of elements in A and the number of elements in the other set, which is B intersection C. So we're told also that the number of elements in A is 6. So that's just going to be 6 here. And if we want to find the number of elements here in B intersection C, well, to find that, we'll just have to divide by 6. So the number of elements in B intersection C is going to be 24 divided by 6, 4. So you can see how we use this important idea. So in example number 4, we see our friend again here, the number of elements in A cross B in this intersecting with A cross C, and as we saw in our last example, that's equal to the number of elements in A with the cross product of the number of elements in the intersection of B and C. So when we're looking here, the other interesting part here is we're looking at the maximum and the minimum values for the number of elements. We're told the number of elements here, here, and here of all the different sets. So they're going to occur either when they're a subset or when they're disjoint sets. So the first option we could have is that we've got A is just going to be A regardless, but there's two different options. We've got the subset and we've got the disjoint alternatives for when we have the sets B and C. So these are the interesting sets here. We're interested in sets B and C. Now, which one's bigger? It looks like set C is bigger than set B. So in this case, C would be the larger set, B would be the smaller. And here it doesn't matter because they're disjoint anyway. So let's fill in the number of elements into each set. So B, there are 8 elements. And for C, there are 11. Now here, all 11 are still in here, but in the subset, they've got 8 already included in B, so that leaves the remaining 3 to make up the 11 elements in C. So now it's just a matter of working out this product and seeing which is the maximum, which is the minimum. So the number of elements in A is 5 each time, so 5, and we multiply that by the number of elements in B intersection C. Well, the intersection there is 8. And so that's going to be 40. Let's try the disjoint. So the number of elements is 5. And the number of elements in the intersection, well, there's no elements because there is no intersection. And so as we can see here, this is the maximum value, and this one here will be the minimum.